Hello and welcome back. So this video is for class 10 and we will continue with the chapter of electricity. So in the previous class we saw the very important Ohm's law, right? So here is what we saw. We saw that according to Ohm's law, V is equal to IR. That is, the potential difference across a resistor will be equal to current multiplied by the resistance. Now this R, that is the resistance, is a very important property, correct? Now we will say that resistance is a property which will oppose the flow of electric current. So generally, whenever we want to control the current in a circuit, we will use a resistor. Now there is some confusion that some students have. Okay, so we are going to try to solve that confusion. So here we have one resistor having resistance R that we are going to connect to a power supply, to a battery having potential difference V, right? Now I am going to connect two ammeters here. One ammeter will be here, okay, and the other ammeter will be on the other side, right? So this will be minus, this will be plus. Let me call this as A1 and this I will call as A2, right? Now we know that because of the resistance and because of the potential difference, we are going to get some current I. Okay, so let us give some imaginary values. For example, let us say the voltage is 10 volt and the resistance is 5 ohms. How much will be the current? You will say I will be equal to V upon R, that is 10 upon 5. So you will get for this combination, I will get as 2 amperes, correct? Now here is the question. Now I have a potential difference V over here, correct? Now the current is going to flow through the circuit. I have two ammeters, A1 on this side and A2 on the other side. Which ammeter will give a reading of 2 amperes, okay, and which ammeter will give a less reading? So many students, they feel that because current is starting from here, so we will get a higher reading in this side, okay, on A1. And because I have a resistor, that resistor will stop the current. So now in A2 the reading will be less, but that is not the case. In both these ammeters, you will get the same reading, which is 2 amperes. Okay, so when we say resistance is opposing the current, this resistance is going to affect the current in the entire circuit. Okay, it doesn't matter on the left hand side of the resistor or right hand side. Okay, so always remember this, resistance will control the current in that entire line. Okay, so on both these ammeters we get the same reading, which is 2 amperes, correct? That will be controlled by potential difference and resistance. Of course, if you change the voltage, the current reading is also going to change. So make sure that you have understood this concept. Next, we are going to talk about a concept that is called as resistivity. Now let us see what is meant by resistivity. Now if you take any kind of resistor, right, it will have some resistance R. Now that resistance will actually depend upon a number of factors, correct? There are actually 4 factors which will control the resistance. One is length, the other is area of cross section, third is temperature, and the fourth is the material. So which material you are using, that is very important. So let us say we have finalized a particular material, so that factor is gone, correct? So now 3 factors are there, length, area, and the temperature. Let us say now we are keeping the temperature also constant, correct? We are not changing the temperature. So now only 2 factors are there, which are length and area of cross section. So when the material is the same and temperature is constant, the resistance will depend upon 2 factors. Which are those? Length and area. And how does it depend? We say that the resistance is directly proportional to the length L. Means your resistor, how much length it has, correct, depending on that length the resistance can be controlled. Means if you are having 5 centimeter of one resistor and 10 centimeter, the one that is having 10 centimeter will have more resistance. So resistance directly proportional to length. As the length will increase, resistance will also increase. So that is first factor. The other factor is that resistance is inversely proportional to the area of cross section. Means if area of cross section is more, the resistance will be less. Okay, means if you are having one resistor which is very thin and the other resistor is a little bit thick, correct? So out of these two resistors, you can see this one is having smaller cross section area. So here the resistance will be larger, and for this one the area of cross section is larger. Here the resistance will be lower. Okay, so remember these two things: resistance directly proportional to length and resistance inversely proportional to the area of cross section. Combining these two, we can write R proportional to L upon A. Right, now we are having the sign of proportionality. To remove that, we add a constant, so we get therefore R is equal to the constant we add is this. Okay, this is pronounced as rho. So we get R is equal to rho, which is the constant, into L upon A. Okay, so this rho, this will be equal to, rho will be equal to then R A by L, and this rho is known as the resistivity. Okay, so resistivity rho is equal to R A by L. Now what is meant by resistivity? Let us see. So we got the formula for resistivity as rho equal to R A upon L. Right? Now we want to have some kind of value for this. So let us assume that we are having a resistor where the area of cross section is 1 meter square and the length is equal to 1 meter. So A is also 1, L is also 1. So how much will be rho? Rho will be equal to R. So we will say that a resistor having unit area of cross section and unit length will have a resistivity equal to its resistance. Okay, or another way of saying it is that the resistivity of a material is defined as its resistance for unit area of cross section and unit length. Correct? That is the meaning of resistivity. Okay. Now, what is the SI unit of resistivity? SI unit of resistivity will be ohm meter. Why we get ohm meter? A resistance ohm, area meter square divided by length meter. So meter square upon meter will be meter. So SI unit of resistivity is ohm meter. Okay. Now make sure that these two words you are understanding very carefully. That is, one is resistance and the other is resistivity. Okay. Now what is the major difference in them? You see that resistance will change with length and area of cross section with the physical dimension, but resistivity will remain constant. So if you are having a copper wire, for example, okay, so copper wire, one is having 5 centimeter length, other is having 10 centimeter length. Okay, same area, which will have more resistance. 10 centimeter wire will have more resistance. But what about resistivity? Both will have same resistivity. Okay, so resistivity is a constant. So basically, we can actually classify materials based on their resistivity. So we say that the materials which are good conductors of electricity, they have low resistivity, and the materials which are poor conductors, they have high resistivity. Okay, making sense? So that is the concept, and this difference is very important to understand. Okay, next you will learn the formula of resistivity. Rho is equal to RA by L, resistance into area upon length. Okay, and the SI unit of resistivity is ohm meter.